I will start. Yeah. Hi. Good morning. So you had a very intense discussion for policies. So now we will chill out a bit. Yeah. So if you don't know me, I'm Jo or Georgia. I come from Greece and I work as a STEM data steward in Czech Republic. And just so you know who is speaking to you. Yes. So we will talk about Readme files, and it's an introductory course, but we'll go a little bit through history and how they came to be. So first of all, as I said, we'll talk about the history of Readme files, but we'll also go through some today's examples in usability, and then I will show you the project of Readme files that we are doing with the Czech Data Stewards community. And if you want to participate, you're more than welcome. So we will try today the first template that is out from this community. Have you ever seen a Readme file? Can you? Yeah? Okay. Anyone who has never, ever? No. You have all downloading something, okay. And have you ever created a Readme file? Someone who's never created a Readme file? Perfect. That's even better. So, because I think this will be helpful for you. So, Readme file history. So, if you have seen Readme files, but if you have never created a Readme file, you might not understand a bit the logic about them or why did they came to be. So, a Readme file in general, very general, looks like this. This is a Readme file for a software. It says it's a Readme. It has a logo created with just symbols, and then it has some contact, and more information is below how you can use something. So what a Readme says usually is what to do, how to do it, what not to do, and who to contact if you have any problems for a project, for a software, for something. And in more specific terms, especially for software, Readme files are known to have installation instructions, but they also mention known bugs. So if I have a software and I know it's crashing with a specific system, I can write it there so other users know that, if this happens to me, there's a solution, it's in the Readme file, so I can follow these instructions to solve my problem. And there is always a change log, which is basically a type of versioning. So you mentioned there what has happened in the last version and what did you change and why usually. And this is to make it easier for others to understand. And Readme files are basically a user-friendly manual. So it's not like fancy documentation. It's more about, this is what I did, this is the recipe. And if you get stuck and you put too much salt, this is what you can do to fix the flavor. Yeah? So this is what they are about. But how did this start? So the first, let's say, documented Readme files are found around 1970s, but these are the ones that we have digitized. There might have been Readme files before. There are online discussions in forums that they have been in 1960s or even before. But in 1970s, we have these two Readme files that are considered among the first Readme files, so 74 and 75. And people are discussing online all the time about this. If you believe it, people really find this interesting because we don't have the actual documentation of who did it first. So there is this discussion. And what is very interesting to me while I was trying to make this presentation for you is I found out that there were Readme files printed in real paper to give instructions on how to use punch cards. Punch cards were a type of data. So I will show you exactly what punch cards are. So punch cards for data, yes. So the punch card, the same that you have in train, that the train conductor comes and punches it, yeah? Think about it the same, and they had stored data in them. So there would be, I will show you exactly how it looked like. So you definitely know magnetic tapes or disks that were used for storage, but this in magnetic tapes, for example, started being used around 1950s. Even though they existed from 1928, they were not really famous. And before that, people would store their data in stiff paper, so in carton. I didn't know that. I found it so interesting. So you basically would have a stack of cards, and each card would have holes in it, and based on the amount of holes and absences of holes, the card would be read by a metal brush, and when there was a hole, this metal brush would basically create a circuit, and this would give an electric pulse to the computer, and it would read the data. And this would be either instructions or it would be data themselves. And these cards would be possible to be fed to card readers between 100 and 1,000 per minute. And you had to do it manually. So imagine if it fell down, you had to start all over. And one process could take around 30 hours in total to load this data on the computer. And this is how it looks like. These little red gaps are the holes. We call them holes, but they are square, and their shape is based on storage capability. So through the years, they changed from round to square because it helped to store more information. This is a statement from Fortran. So basically, the metal brush would go through. Wherever was the hole, it would be the pulse. This has a specific situation. Other cards would have, of course, different places of hole. So the Readme file would be, I don't know, behind of this card maybe, or in a different punch card, so you could read it in an actual printed document. And these punch cards, of course, were for other reasons before data. And basically, they were called also IBM computer cards because IBM was one of the biggest creators, let's say, of this card. They had a huge business about it, and around 1950s they started changing to magnetic tapes. And actually, this punch card would have a lower amount of holes before, but through the years they increased this amount of holes, and the final number was 12 rows and 80 lines. I hope I said it correctly. Yes. And this is actually why we have the 80 character limit in the command line in some systems still. So this is about punch cards, a fun fact actually. And this is what I found as the first Readme file, and I cannot promise it is the actual first, but you can find it digitized today. It was donated to public domain. I have cut it, of course, because it was much bigger, but what I wanted to show you is that it doesn't really differ from what we are doing today for Readme files. So in the beginning you have the title, the Readme file of this, you have the specification of where this is useful, and any requirements you need to work with this software. And then there is a note by the author that says there was a hacked up version, and I don't want to discuss it more, so stop asking me. And I love this one. And here you see they have abbreviations and explanation of what this abbreviation is. And this is exactly what we're doing also today with Readme files. And in the end, we have a nice goodbye, good luck, and the name with the date. And the other Readme file I was talking about is from 1975. And I love this even more because it's absolutely true. Random notes, yeah? Readme files are actually often just information we have and we don't know where to put it. So random notes instead of Readme file here. The file itself is called a Readme file, but it talks about, for example, bugs that we talked about. So he says, if you have this problem, the system is not working, so you need to do this and that to make it operate with your system. And again, if you need help, you have to contact this department. So it's a very nice start, let's say, for the Readme file history. And actually, we had this discussion with a lot of data stewards, and I don't know if you know this, but the Readme file has a reason why it's written with capital letters and not with small letters. Of course, today you can write it any way you want. But the reason is because in the system that translates the human text to the dyadic text, to 0100, for computers, actually sorts files based on not just alphabet, but also if they are capital or not. So any capital lettered documents would be sorted on top, and any lowercase would be sorted after. So usually any script or any executable file will be with lowercase names, while any documentation would be with capital letters. So, usability and examples, and I hope afterwards you can check the list of references, because there is a huge amount of Readme templates, Readme examples, and everything like that. This is a repository in GitHub with a curated Readme list. It's huge, actually. I just took a picture. It has examples of pretty Readme files. So basically, they are different softwares or templates. And if they have a nice view when you open them, and if they are structured correctly, the people who are curating this list add it here and add some description. And you can find a lot of Readme examples here. One of them is this one, where they're using a nice GIF. This is actually movable, just took the screenshot. And there is Markdown, and they explain how you can use their program. There is this blog that's called Art of Readme. And basically, I changed a little bit the text. But what I got as the point of this discussion was that when you're making a Readme, you're trying to save people time. So basically, if you spend these few hours to create a Readme for others, to be able to use your product in an efficient way, you're saving a lot of time from everyone, because you would spend a few hours, but if someone needs to interpret what you were thinking when you were creating something, they will spend, I don't know, 5 hours. But 100 people spending 5 hours is 500 hours. Well, you would spend 2 to write them a Readme. And one last of the Readme best practices is this template, which you can actually just download the template in Markdown, and you can use it in your own system. So it's a Readme file template that you don't need to do anything. You just fill in the information, and that is it. But my dogs were asking me if this is really Readme files are only for software, and why are we talking about it? Because we're data stewards, Mom. So I told them they are not only for software, they are also for datasets. So they were much happier after that. And yeah, Urgal especially was very happy. Actually, yes, since the 2010 approximately, where data repositories started to have this burst and start being created, and they were allowing people to deposit their data without any other publication. Finally, this is when we started to have a standard practice of having Readme files also for datasets. And here is an example. Sorry, I will go away. Here is an example. I have modified a bit what I found from a team in Cornell University. In general, Cornell University has some of the best informations on data and data stewardship. So if you ever need to read about anything data stewardship, go to Cornell University Library and you'll find everything. This is some of the basic information we put in a data Readme file and not in a software Readme file. So it's very similar, yeah? We put the general information, so what are you talking about? Which is the name of the data set or the data project? We need always someone to contact, either a department or a person, and then we need to explain the file names, the file formats, what are the terms of use. We never forget the terms of use. And they are important to be added to the Readme file and not just to the repository, because when the people download your stuff from a repository, cheers. When they download your stuff from a repository, the license does not go with this. So if you put it in the Readme file, they actually still know how to use your data, even without being in the repository. And what I find one of the most important parts in a Readme file is the methodology. And you might wonder, like, why should I add the methodology? I've written the paper, it says everything. Yes, but there are a lot of reasons why papers go down. For example, they disappear from the paper journals from online. So there is a practice to be adding also your papers on a repository, but also you don't need a paper to actually deposit your data. And this is the best practice, to deposit your data without having a paper specifically. So basically, if you have all this information in the README file and make it user-friendly and not fancy, so not I made this fantastic method and it's amazing, but like actually, this is how you work with it, click 1, 2, 3. This is how people can actually repeat your experiments and do the same research like you. And in Dryad, you can also find some You can also find some instructions about, it's very similar. They give some information about how to create a README file for the Dryad repository, but I cut down the parts that I find important in any README file. So summary again, structure of files, licensing. Licensing is very important to be mentioned in the README file. And a very interesting part was they said not to include author names if you wish to go under a double peer review, because this way it could be identified. I don't know how exactly you would do that, because when you put your data in a repository, you already have the author name there. So if it's only online, it might be a bit tricky, but it's a good idea, so think about it yourselves. And now I will show you the README file projects of the collective of data stewards. We're doing this project under the National Repository Platform, but the people who are actually doing it are not all under the project, but they are very nice to actually want to contribute. And we are called the collective of data stewards to have a more generic name and not to have to list every other person all the time. For example, the collective of data stewards is just a team we gathered in the Czech data stewards community, and it's quite open. And what we decided to do is to create a README template. And after that, for each discipline that we have knowledge to create examples for, we fill in this README template with the different examples from each discipline. And we actually have 80 disciplines. We don't have people who can fill all of them. So if you're willing, I will show you the QR code later, you can join. We have quite a lot of them, like at least half of them are planned to be filled in. And at this stage, we have created the template of the README file, and it is in 3 formats. It is in text, in Markdown, and in JSON. We have these 3 formats because some people are not tech savvy, and they are not. They should not be not able to fill in the form. But also we have Markdown to make it more computer friendly, and then the JSON is to have it completely machine actionable version. Now we have to add the specific examples. So the specific examples are not yet out, but I will show you how it looks like. Am I speaking too fast? Because no, it's fine. Okay, so I will actually show you the actual thing. This is just a picture. This is the text. So you see there is no special symbols or anything. But then we have the Markdown, which looks much prettier, and the JSON, which is computer language, basically. And now I will give you the QR code, and you can go to test it yourselves. We will separate into teams. Thank you so much for taking your time to look at it at least. And enjoy lunch. Thank you.